Hey guys, Zino with you, and today we will be talking about crude oil. There are 9 specification points, and I will go through each one of them with you guys. So, to start, now we are on specification point 5.6, which assures you should understand that crude oil is a mixture of hydrocarbons. So, you must be asking, what is a hydrocarbon? A basic definition is a hydrocarbon is a compound containing carbon and hydrogen only. And because there are hydrocarbons in crude oil, uh, there um, there are 4 of them actually. And the first one is methane, as you can see here. Methane, which is CH4. Ethane, which is C2H6, 2 carbons, 6 hydrogens. Propane, which is 3 carbons, 8 hydrogens, and finally butane, which is C4H10, which is commonly 4 carbons and 10 hydrogens. And we are on to specification point 5.7, which you describe and explain how the industrial process of fractional distillation separates crude oil into fractions. So first of all, the crude oil goes through the processor here, the one I'm circling at, and it goes through these stages. It goes through 1, 2, 3, 4, 5 stages until it reaches its final stage. And the first stage is refinery gases, gasoline, naphtha, kerosene, diesel oil, fuel oil, and final residue. We will be going into more detail about that in the next specification point 5.8. But just to clarify, there are 2 points, temperature points in the system. The coldest point is at the top, which is about around 25°C at the refinery gases, and the hottest point is at the residue or bitumen at 350°C. So we will just draw a simple line signifying it, and there, from that point is the hottest point, and from that point there is the coldest point. As you go down, the temperature increases. And now we move on to specification point 5.8, where it is similar to 5.7, but now we will go into more detail about the stages that crude oil offers. So, first of all, it goes through the process, and at first it gives you fuel oil. Now, fuel oil is used for ships, for power stations, and such. Then that is the first row. The second column row is diesel. Diesel oil, fuel for cars, fuel for trucks. Um, it is used for high-powered vehicles and related. And then the next stage is kerosene. Kerosene is mainly for aircraft fuel and for lights, like matches and such. So then you go up to naphtha. Naphtha is a kind of chemical, well, a sort of, and you make chemicals with it basically. And you go up to gasoline, petrol, as we all know. Fuel for cars. You could see there is a dollar sign there, over there, because basically, if you have gasoline, you have money. So, and finally, comes out is refinery gases. These are cooled gases, only at 25°C. Those the flames that you see sometimes at manufacturer sites, those are products of refinery gases. And at the bottom, which is the hottest, 350°C, over here is residue slash bitumen. Now, bitumen is used for roads, it is used for lubricating oils and related. Now, it is black, and as you could see, it's kind of crumbly. It's mixed, sorry, with the small pebbles and rocks to make the roads. And on the right here, you could see that a real life example of fractional distillation over there. Yep. And with that, we move on to specification point 5.10, which states that you should understand that incomplete combustion of fuels may produce carbon monoxide. Now, carbon monoxide is an odorless, colorless gas that is produced from incomplete combustion of crude oil and its hydrocarbons. If breathed in, it reduces the capacity of the blood to carry oxygen, therefore being dangerous and in most cases fatal. Now, clearly it's dangerous. You can see in this banner poster thing, first, the signs of it is headaches, nausea, dizziness, breathlessness, obviously because it reduces the capacity of the blood to carry oxygen. Uh, you eventually collapse, and from not enough air, um, you get unconscious, basically. And a picture of the bond is basically C plus O. There, black, red, CO. And yep, CO, danger, carbon monoxide. Now, in most countries, for example, the UK, they have sensors for this type of thing, carbon monoxide sensors that basically measure the levels of the monoxide in the air. If it is over this amount, it rings and basically notifies you. And now we move on to specification point 5.12. Understand that nitrogen oxides and sulfur dioxide are pollutant gases which contribute to acid rain, and describe the problems caused by acid rain. So to start with, if there is insufficient air for complete combustion, we get incomplete combustion instead. The hydrogen is still oxidized to water, but instead of carbon dioxide, we get carbon monoxide. Particles of carbon seen as soot or smoke are also released. So now you could see a short diagram there, small one. So from factories, CO2 and NO2 are released from the fumes. They go up in the clouds, sorry, and they form in the water droplets, which therefore fall on the city with vegetation. Now, all parts of the world are affected, and not just the areas that have more pollution. The worst areas that cause acid rain are Europe and North America. This is because these are more developed countries, and so therefore we have more money to pay. They have more money to pay for electricity and cars. But generally, the areas that are more affected, the worst by acid rain, are the tropical forests as well as rivers and lakes. Quick fact there: the Czech Republic has suffered the greatest damage to forests caused by acid rain. A mind-boggling 71% of the country's forests are affected. So, shit. What? Okay, now with that, we go on to specification point 5. Okay, now guys, we are on to specification point 5.14. Describe how long chain alkanes are converted to alkanes and shorter chain alkanes by kettle cracking using silica or alumina as the catalyst, and a temperature in the range of 600 to 700 Celsius. Now, you might be asking, what is cracking exactly? We have two pictures here. I can tell you from now, none of them are cracking. Okay, and now cracking is useful process in which large hydrocarbon molecules are broken into smaller ones. That is a basic definition. Um, I can give you a long one if you want. So now, long chain hydrocarbons are passed over a hot catalyst. This causes them to break down into smaller molecules. As some atoms are lost from the molecules, they become unsaturated and can therefore form a double bond. This is how you get alkenes, from the process, as well as shorter chain alkanes. So now there is a diagram there, and that is a long chain alkane with cracking converted to a short one. Now we have come to the end of this presentation. We have covered specification points 5.6 to 5.14, and thank you and goodbye.